Hello, happy Tuesday, and welcome to Zoom Into the Void for June 2022 with the Danville Science Center. June features a wide collection of celebrations, including being National Zoo and Aquarium Month, National Pollinators Month, Pride Month, and National Great Outdoors Month. We're beginning today's survey of the sky by transporting outside, like we always do, to the backyard of the Danville Science Center using the sky viewing software Stellarium. We are facing the south with east to the left, west to the right, and north directly behind us. Gazing in the corner, we can see it's just a minute past noon on the 14th of June, 2022. Gazing skyward, we can find the sun high above us in the sky. The sun will make its highest and longest apparent journey across the sky a week from today, June 21st, as we welcome the summer solstice, the season when the northern hemisphere is most tilted towards the sun, experiencing the maximum amount of direct sunlight. Moving through the day to just after sunset so that we can get rid of that sunlight, we can spot some other objects in our brightly illuminated sky. The June night sky can be disappointing for planet watchers, as we will not spot any during the nighttime hours this month. However, we can find a rich collection in the early morning hours. More on that to come. What we can spot is the familiar Big Dipper asterism high in the southwest. Moving our eyes down into the east, we find the fourth brightest star visible from the Earth, the red giant Arcturus, the brightest star in Boots, the herdsman. Continuing our eyes downward, we spot another one of the brightest observable stars, Spica, within the wheat within the hand of mighty Virgo, the maiden. Finally, moving our eyes back up and to the right, we discover Denebula, the brightest star in Leo, the lion. Connecting these three bright stars forms a shape known as the spring triangle, an asterism, an unofficial pattern of stars. There are 88 universally recognized, there are only 88 official constellations, but there are hundreds of asterisms. The Big Dipper is an asterism within the constellation Ursa Major, the Great Bear. Continuing on through time to tomorrow morning, just after tomorrow morning, so we'll go another, 2 hours. Looking at the museum, right around the change of the day, right around midnight, we can spot moonrise coming up around the corner. Continuing on to 2 a.m., we can find giant Saturn lined up with the moon. Continuing on to about 4 a.m., we see giant Jupiter, and right by 5 a.m., we can find Mars, just as the sun is rising to wash out those lesser lights. These planets look great lined up, but we will see an even more ideal planetary parade the morning of the 22nd, one day after the start of the summer solstice. Around 5:30 on the 22nd, if you have a particularly clear skyline, in fact, we're going to go ahead and remove the museum, then we see also Venus and Mercury joining this parade. We can find all 5 of these planets above the horizon for just a few moments, again, before the sun rises and its light causes all these others to be too difficult to see. Despite the lunar entourage, we are not focusing on the moon this month. We did that in May. Instead, we're taking a close look at the sun. There is still so very much we don't understand about our central star. Most of what we currently know has been a change from what we thought we knew. We do know that the sun is the center of our planetary system, the solar system. At least, we know that now. Up until the 1500s, the Western world understood the Earth to be the center of the universe. And why not? it made sense. We look up into the sky and observe objects moving. Therefore, we must be stationary with the other objects orbiting around us. This is known as a geocentric view of the system, meaning Earth-centered. Over time, though, this model was criticized, given its inability to address certain phenomena. The geocentric model did not have an agreeable method for accounting for the differing velocities of the planets as they orbited. It also didn't account for parallax. Try the following experiment. Hold up one finger, then close one eye, and focus the other on your finger. Now, switch eyes. Switch again, back, switch, back. What did you observe? Did it look like your finger was changing position? This is parallax, when an object appears to change location or direction when observed from two different points, not in a straight line with the object. Stars and other celestial bodies experience parallax when observed from two or more different locations on Earth. However, the stars being so very far away makes the parallax negligible to casual observance. Try the finger experiment again, but this time, slowly move your finger away from you as you switch eyes. Did the amount of apparent shift lessen as you moved your finger further away? Perhaps the greatest challenge to the geocentric model was planetary retrograde. You may have heard about Mars's recent retrograde are experiencing unusual occurrences during Mercury retrograde. Neptune will enter retrograde on the 28th of this month. Planetary retrograde motion occurs when a planet appears to change its orbital direction. That is, Mercury usually appears to move through the sky west to east. But when it enters retrograde, it appears to change direction, moving east to west. Planetary retrograde is not an uncommon occurrence, and geocentrism did have an explanation: epicycles. But it also eventually fell out of favor, because math. Enter the year 1543. Polish astronomer Nicholas Copernicus publishes his book De Revolutionibus Orbium Coelestum, on the revolutions of the heavenly bodies. In it, Copernicus argues that the planets in our system do not collectively orbit around the Earth, but rather around the sun. This heliocentric model, derived from the name of the Greek god of the sun, Helios, would be built upon by future astronomers to this very day. Johannes Kepler used it in explaining the elliptical rather than circular orbit of planets. Isaac Newton in explaining planetary motion, and Galileo provided further support for the heliocentric model through his observations of Jupiter's 4 largest moons. A shift to acceptance of the heliocentric model was not just a scientific one, but one that affected philosophy, religion, art, all aspects of thought that eventually resulted in the Copernican revolution of the Renaissance. Challenges to establish understandings are often met with strong, at times violent, resistance. Copernicus, however, faced little of it. In the year 2022, conflict between seemingly contradictory explanations of reality is easily observed. For example, if your earth science teacher explains that human actions have caused the planet to warm to unsafe and unsustainable levels, but your Sunday school teacher explains that the earth naturally goes through periods of climate change, then you have experienced an apparent contradiction, one that can result in strong feelings. At the time of his great reveal of the heliocentric model, Copernicus was actually under the employment of the church. The dedication of his seminal book was to the Pope. Meanwhile, the Protestant Reformation was gaining steam, and fundamentalist Protestants were increasingly voicing their disagreement with a sun-centered model of our system. As their resistance gained more attention, the Catholic Church also eventually began denying the heliocentric model. Resistance at times became violent. One philosopher was put to death for suggesting that Earth not being the center of the universe meant that humans were not the pinnacle of creation. In 1616, in response to Galileo's increasing popularity, the Roman Inquisitorial Commission declared the heliocentric model to be foolish and absurd, with then Pope Paul V banning Galileo from teaching or even believing it. Galileo resisted and continued publishing works featuring a sun-centered system. In 1633, the church sentenced him to spend the rest of his life under house arrest. It would not be until 1758 that the church adopted and officially declared non-heretical the heliocentric model. America was founded in 1776. Advancements in science, technology, and yes, religion have resulted in the validation of the heliocentric model that is our solar system. While we have gained a greater knowledge of the sun's location, there is still a lot we do not understand about our central star. Perhaps the greatest tool for modern solar discovery is NASA's Parker Solar Probe. Launched in 2018 with a specific mission to touch the sun, the Parker Solar Probe has made the closest successful approach to the sun to date at a distance of 5.3 million miles. By 2025, it is expected to get even closer at a distance of 4 million miles. Remember that the sun is 93 million miles away from Earth. Through solar orbit, Parker is studying solar weather. Due to the natural shifting of the poles of our star, the sun's magnetic field experiences occasional fracturing. Plasma can escape through these breaks, launching material into space in the form of solar wind and weather. Solar storms can do harm to technology in space and here on Earth, damaging global positioning satellites, cell phone reception, and in extreme instances, causing power grid blackouts. Better understanding of solar weather will aid in our ability to predict and prepare for solar storms. We hope that you do not experience any extreme weather while enjoying June's increased sun exposure, and we hope that you will join us again next month here in the Void as we explore July's sky, the second Tuesday of the month, July 12th. Until then, keep discovering your world. Bye.